Hi, Integrated Math 1. Welcome to lesson 4.1.1b, day 2, where we're still graphically representing data. So last time we really dug into dot plots and histograms, right? We said a dot plot was great because you could spread out the data and look at the distribution, see how things are spread out. The problem is a dot plot was only good if you had a small number of points. That if we had a lot of points, a lot of things that we were trying to look at, the dot plot got to be a bit much, and so we preferred a histogram where we put things into bins, right? We had our little intervals, our little bins, and then the frequency was the height, right? How many things were in the bin was our frequency that said how tall the bar went on our histogram. So we're gonna start digging into box and whisker plots today. Again, representing these things, but also, how do you make it? How do you draw it? But also determining whether or not it's the best way to display the data. So we said dot plots are great if you have a small amount. Histograms are great if you have a large amount. So when would we want to use a box and whisker plot? And we're going to be able to use our box and whisker plots to compare two different data sets. That might be a clue as to when it's good to use a box and whisker plot. So yeah, key term today is definitely going to be box and whisker plot. And along with that, we're going to get something called a 5-number summary. Okay, so keep that in mind. That's going to be happening. So you know how to represent and interpret data using dot plots and histograms. We're going to dig more into those box and whisker plots. And we're going to dig more into that idea of which representation is the most appropriate. Now, if you recall last time, we were talking about lead levels in the water, right? And we discovered an issue in Greenville. We were like, oh my gosh, they have way too many sites that have way too much lead in the water. And the cutoff was 15 parts per billion, right? Lead concentrations in drinking water should be less than 15 parts per billion, or ppb. If they go over that, we have a problem. People are going to get sick. It's very, very bad. So the governor has now gotten involved, right? We know last time the mayor of Greenville was like, oh my gosh, we have way too many sites over the levels. We have to do something about it. So the governor wants to compare the amount of lead in the drinking water of different cities in her state to see where improvements in the water system should be made. So we know Greenville's got a problem. But we're now going to compare that to other cities to see if there's a trend or if there's areas of the state that we should be taking a closer look at, right? And what's going on in those places that have such high lead levels. So you can visually compare two large data sets just at a glance using box and whisker plots. So a box and whisker plot is a graphical representation that displays the distribution of our quantitative data based on what we call a 5-number summary. It's very easy to find those 5 numbers, and then once you have those 5 numbers, you use them to create a box in the middle and then whiskers out the end. It's the box and whisker plot. That 5-number summary consists of the minimum value, right? Smallest one there. What we call the first quartile, we'll talk about that in a bit. The median, we talked about that at the very start of the lesson last time. That's the number in the middle, right? The third quartile, which we'll talk about in a moment, and the maximum value, so the very, very, very biggest number there. So 3 of these we already know. We already know minimum value, smallest number there. Maximum value, biggest number there. And we know the median is the one in the middle if you line them all up in order. So let's talk about that first quartile and that third quartile, shall we? This is how it works. Here's our minimum, here's our maximum, and of course the median would be the value that's sitting in the very middle. Now please notice, there's a number line, kind of like our dot plots. We do a number line, only instead of making little 2, 2, 2, 2, 2 X's up above, we put our minimum, our maximum, our median, our quartiles, and then we connect quartile to quartile with a box, and the median gets trapped in the middle, and then we connect with whiskers out to the ends of the minimum and maximum. So this creates 4 chunks of data. That's why these are called quartiles. A quartile is the median of the lower half of the data. So this is the lower half of your data. The quartile is the middle guy of the lower half. Right? That means the third quartile, you see it, The third quartile is the median of the upper half of the data set. So we found our median, which split our data in half. You picked out the guy in the middle, so here's our two halves. Well, then the first quartile is the middle of the lower half. Got it? Middle of the lower half. And then the third quartile is the middle of the upper half. So we're literally like end, end, middle, middle, middle. And those are your 5 bits. So it actually cuts your data into 4 sections. When we pull out those 5 numbers, you can see it creates a section from minimum to the first quartile. It creates a section from the first quartile to the median, a section from the median to the third quartile, and a section from the third quartile all the way to the maximum. Because we literally went end, middle, 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 it means that each of these is a quartile. Each of these has a quarter of the data in it. Quartiles. You get it now? Do you get it? So that means 25% of my data is in this whisker. 25% of my data is in that part of the box. 25% of my data is in this part of the box. And 25% of my data is in that last end whisker. Are you getting this kind of in your head a little bit about why they're called quartiles and this whole box and whisker plot thing? It's so cool. So the 5 number summaries of the data for the amount of lead in drinking water samples taken from the cities of Greenville and Oaktown are given. Greenville should look familiar to us. We played with these numbers before, didn't we? But now we have the data from Oaktown as well. So we're going to construct a box and whisker plot of the data for each city, and we're going to put them both on the same number line, okay? So let's start off with our number line. Looking at these as a minimum of 1, a minimum of 2, a maximum of 22, and a maximum of 15. So this says to me, I need to make sure my number line goes all the way from 1 to 22. So just to start, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. Awesome. You may even want to make a little note here that that's the amount. I don't have space below. You have space below. Oh my gosh. I'm making a mess. I'm going to fix that. That was a mess. My bad. I will fix it. We're going to call this the amount of lead, right? Because that's what all this is the amount of lead. Now, I'm going to use a couple of colors here just to make it a little easier. Let me grab my blue. Let's do our box and whisker plot for Greenville. To start off, I'm just going to make marks up above on each of these numbers. So my minimum is 1. Oh dear, my minimum is 1. I'm just going to make a little notch. Quartile 1 is at 8, so 5, 6, 7, 8. So there's quartile 1. My median is at 12, so there's the next one. My third quartile is 16. Boom, there's that. And my maximum is all the way up at 22. Woo. All right. So here's my 5 number summary. 1, 2, 3, 4, 5. All 5 numbers are there. Minimum, quartile 1, median, quartile 3, and the maximum. To make my box and whisker plot, I start with my box. My box includes these 3 guys in the middle. So I'm literally just going to connect quartile to quartile. Shoo. Boom. There's the box of my box and whisker plot. But it is a box and whisker plot, so I do need to make whiskers. So the whisker is just going to come from the middle here all the way up to the middle of that first quartile. And then I'll do one on the other end. From the middle of my third quartile, make my whisker all the way up to the middle of my maximum. And we just made a box and whisker plot for Greenville. So I'm going to label it, oh dear, I'm going to label it Greenville, only if my pen will cooperate. Oh, wow. I'm going to write it over here. My pen does not want to cooperate. I'm going to write it somewhere. Greenville. And yes, I know I just drew Greenville in blue. It's okay. Can you please, just up above, do the box and whisker plot for Oaktown. You're not going to make a whole new number line. You're just going to do it directly above Greenville, so we have a nice direct comparison. Hit pause, make your other box and whisker plot, and then hit play when you're ready to check your work. All right, I'm going to grab another color. Now I'm going to use green, but not for Greenville, for Oaktown. So my minimum is at 2, so I make my mark here at 2. Do I have, oh, there's the green. So I'm going to make my mark at 2. My next notch is at 6 for my first quartile. My next notch is at 8 for my median. My next notch is at 9, whoa, for my third quartile. And then my next notch is at 15. That's all the way up there for my maximum. The middle 3 become my box, right? The middle 3 become my box, quartile to quartile. My whiskers go out on the ends, boom, boom. Wow, that was a long whisker. And I do need to label it. That is, of course, Oaktown. Awesome. Oh my goodness gracious. Oh my goodness gracious. So, wow. That's really direct comparison because they're right on top of each other, right? I've got Oaktown up top. I've got Greenville on the bottom. Suppose you work in the governor's office. Compare the data displayed in your box and whisker plots and just write a brief analysis to present to the government, to the governor, right? You have to present this data to the governor. What do you notice about this data? Remembering that 15 parts per billion or less is good, okay? Hit pause, write down what you would report to the governor, and then hit play when you're ready to check your work. So I sat down to write my little report to the governor, to write my analysis to the governor, and I noticed a few things. First of all, I noticed that everybody in Oaktown was below the level. Did you catch that? Everybody in Oaktown was below. In fact, we'll come back to this one. It's a little easier to see. 15 parts per billion or less. Everybody in Oaktown was below that. They were either at 15 or below 15. So 100% of Oaktown is okay. I was a little more worried about Greenville because I can see that more than a quarter, remember how that whisker is a quarter of your data? That's 25% of your sites. More than 25% of my sites were over that 15. I felt like the governor should know that. So I said 100% of the sites in Oaktown had no more than 15 parts per billion of lead in the drinking water. So Oaktown was okay. But Greenville, the drinking water in Greenville, 25% of the sites in Greenville had more than 15 parts per billion of lead in the drinking water. In fact, I think it was more than 25% because it kind of bled over into this other quartile, didn't it? Oh my gosh, that's not good. So the governor should probably investigate why the lead amounts are so much greater in Greenville and take action to reduce them. Why are things okay in Oaktown, but they're not okay in Greenville? What's going on? That's what the governor should be investigating, right? What's happening and what actions need to be taken to fix that problem? Because everybody should have clean drinking water, right? All right, so with this in mind, we're going to skip over a whole bunch of pages. Come on over to page 14, all the way over to page M4-14. And I have for you just a couple of questions. I've got a dot plot, I've got a histogram, I've got a box and whisker plot over here. I just want you to tell me what conclusions can you draw from each display? What conclusions can you draw from your box and whisker plot? What conclusions can you draw from your dot plot? What conclusions can you draw from your histogram? Hit pause, tell me what you can conclude, and then hit play when you're ready to keep the discussion going. So I'm starting off with my dot plot. Participants who won gold medals at the Special Olympics. It looks like, so first of all, the dot plot represents the number of gold medal participants won at the Special Olympics. I could count up all my dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I see 20 little dots here, my X's. So I would start by saying that there were 20 participants that were represented on the dot plot. I would agree with that. And this is the number of gold medals that each participant won. So it looks like we have quite a few people that won 0 or 1 or 2 medals, and even on to 3, 4, and 5. But it looks like most participants won a low number of medals. There were a couple, though. I mean, we got 2 people that got 9 gold medals, 1 person that got 10 gold medals. Oh my gosh. We even had, who is this person? We even have somebody who earned 14 gold medals. My gosh. So most participants who won gold medals just won a small number of them. There were a few that won a lot of gold medals. Somebody, always somebody, isn't there? If you took it a little further, you could have added all these up and found that the average was 4.25. If you line them all up in order, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like the median would be between 3 and 4, right? There's 10 dots here, there's 10 dots there. So the median would have been about 3.5. Do you remember mode? Do you remember mode? That's the one that shows up the most often. 1. Most people won 1 medal. Great. What conclusions can you draw from this display? Well, first of all, it's a histogram, and it looks like it represents the inches of rain in the number of months. So 3 months got 0 to 1 inches of rain, 5 months got 1 to 2 inches of rain, 8 months got 2 to 3 inches of rain, 6 months got 3 to 4 inches of rain, and then 2 months got 4 to 5 inches of rain. And I may even just make a little note, like the numbers, just so it's easier for me. So we said that was 3 months, that was 5 months, that was 8 months, 6 months, and then of course we're back down to 2 months, and my pen is still having fun with me. I will fix it. Better. So the histogram represents the monthly amount of rainfall that fell in Collinsburg over 24 months. Because if you add these up, 3 plus 5 is 8, plus 8 is 16, 22, 23, 24. This is actually over the course of 2 years. Oh. Okay, so over the course of 2 years, this many months got this much rainfall, and on and on. So there are 24 data points represented. If we add up all those bars, right, that's 24 months. And I noticed that most fell in the middle bin. Like most of the months, we have more months in the middle bin than in the others. And then it kind of like slid down roughly the same number, right? 3 and 5 is 8, 6 and 2 is 8. So it looks like we've got 8 on this side and 8 on that side, but we also have 8 just like smack in the middle. I can't really determine the mean, median, or mode here because I don't have the specific numbers, do I? But, I mean, still, it's useful in its way. What conclusions can we draw from this display? My box and whisker plot. Volunteer hours at the local animal shelter. Oh, I got my cat at the local animal shelter. She's so adorable. And I'm grateful for the wonderful, lovely people who do volunteer hours at the local animal shelter. They're wonderful human beings who help take care of these lovely animals. So it looks like the minimum number of hours somebody did this was 4. The maximum was 26. Wow, we got somebody doing 26 volunteer hours per week. And it looks like the average, I wouldn't say average, the median number of volunteer hours per week is 11. So this box and whisker plot represents the number of hours people volunteered per week at our local animal shelter. I don't know how many data points are represented. So it's interesting because the dot plot, I could count them up and I'm like, that's how many participants were in the Special Olympics. For the histogram, I could count it up and I could be like, this is how many months we kept track of this data. But a box and whisker plot, I can't do that. I don't know how many data points there are here. I can tell if this is my median, I can tell that 25% of the people were between 4 and 9 hours a week, 25% of the people were between 9 and 11 hours per week, 25% of the people were between 11 and 14 hours a week, and then 25% of people did between 14 and 26 hours per week. So it's interesting because if you think about it, that means this box is half of the people who participated. So it looks like half the people volunteered between 9 and 14 hours per week. And again, I can tell the median is 11, but I have no way of finding, I don't have enough data to find the mean or the mode. I don't have enough data to find any of the others. So I guess this is what we've got. So I find dot plots are great if you have a small amount of data. Histograms are great if you have a large amount of data. And box and whisker plots are great if you're comparing two sets of data, right? I have a set of data and you can do them right on top of each other, like right on top of each other. Makes it really easy to compare what's going on. So as always, guys, I hope you found this helpful. I hope you found this useful. If you have questions or concerns, come talk to me, and I'll see you guys soon. Bye.